acid, base, and salts. In acid-base reactions, you must know the properties for each one. Acid and base. For acid, it is a proton donor, and base, proton acceptor. What is meant by proton donor and proton acceptor? Acid, substance that dissolve in water to produce H positive, and base, substance dissolved in water to produce OH negative. And sometimes we said base or alkali. What is the difference between them? The alkali is soluble base. So base is the solid state. When it dissolves, it forms alkaline solution. So base is a solid. Maybe to dissolve to form alkaline solution, or didn't dissolve to still base. So base, in case of solid, when it dissolve, form alkaline solution. And then we said proton donor and proton acceptor. For example, if we have NH3 plus H2O to form NH4 positive plus OH negative. In this case, NH3 changed to NH4 positive. So it gained H positive. This means that proton acceptor. So in this case, NH3 is considered as base or alkali. While in case of H2O, it changed to OH negative. This means that lose H positive. This means that proton donor. So H2O in this case considered as acid. So the difference between acid and base, acid is a proton donor, base proton acceptor. So acid losing H positive, base gaining H positive. And also for the other definition for acid and base, acid, substance that dissolve in water to form H positive, while base or alkali, substance that dissolve in water to form OH negative. So again, the difference between acid and base, acid, proton donor, base, proton acceptor, acid, substance that dissolve in water to form H positive, base, substance that dissolve in water to form OH negative. And in this case, if we have equation, which one is the acid and which one is base, explain. NH3 forming NH4 positive. This means that it gains H positive. So it is proton acceptor. So it is a base. While acid, H2O, it changed to OH negative, lose H positive, proton donor, so it is acid. After that, for the properties for each one, in pH value and universal indicator, pH and universal indicator more accurate than litmus paper. As we know, in litmus paper, acid, it changed blue litmus paper into red. While in case of base or alkali, red to blue. in pH or universal indicator to be more accurate. What is the difference between litmus paper and pH or universal indicator? Litmus paper only telling us this acid or a base only, while the strength pH or universal indicator. For example, if you have two acids, one of them is strong and one of them is weak. How can we know? By universal indicator or pH paper, we can determine, while in litmus paper we can determine. So litmus paper is not accurate. We can use only to differentiate if we have acid and base, but the strands we can't use. For pH, it is arranged from 0 to 14. You will find 1, 2, 3, 4, 5, 6. This is an acid. After that, we have 7 at the middle. Then 8, 9, 10, 11, 12, 13, 14. To be like that. For 1, 2, 3, the color will be red. Universal indicator. 4, 5, orange. 6, yellow. 7 is green. And then 2, 8, 9, 10. Then purple or violet. These are the colors in universal indicator and the pH degree. For 1, 2, 3, this is strong acid. 4, 5, 6, this weak acid. 7 is neutral. 8, 9, 10, weak alkali. And then 11 to 14, this is strong alkali. So 7 is the neutral, it is green. The area around 7 will be weak acid or weak alkali, and the two sides will be the strong. So the strongest acid near to 0 strength increases as we go into the left near to 0, and also as we go to the right strength increases. This means that if we have acid pH1 and pH5, 1 is stronger than 5, while 14 is stronger than 10. Strongest is here, strongest acid, strongest alkali. After that, for the strong acid and strong alkali, we must know the most common. For strong acids, HCl, HNO3, H2SO4, while for strong alkali, NaOH and KOH. So hydrochloric acid, nitric acid, sulfuric acid, strong acids, and strong alkalis, sodium hydroxide and potassium hydroxide. And we have a different definition for acid and strong acid or weak acid. For strong and weak, if we said a strong acid or alkali, it means that completely ionized. And if we say weak acid or weak alkali, it means that partially ionized. So we have three definitions now. For acid or base, proton donor or proton acceptor, and substances that dissolve in water to produce H positive and substances that dissolve in water to produce OH negative. This is the first definition for acid and base. If we have a strong acid or alkali, completely ionized in the solution. Weak acid or weak alkali, partially ionized in the solution. What is meant by strong or weak? For example, if you have HCl and then make a reaction, you will find it change completely to be H positive and Cl negative. This is strong acid, completely ionized. So completely ionized means that all the reactant to be product. While in case of weak acid, like if we have CH3COOH, you will find it decompose partially and then it will form CH3COO negative and H positive. And then you will find it decomposed partially. So we make one arrows here, but here we make two arrows. This means that it is weak and irreversible reaction. This is partially ionized. Some of the reactant change to product, not all the reactant change to products. The same in the bases. For example, in AOH, you will find it completely ionized. But if we have any other one, you'll find it partially ionized. So here NaOH, it will be Na positive plus OH negative. This is completely ionized. It means that all the reactants becomes products. While weak acid or weak alkali partially ionized, it means that some of the reactants change to products. After that, the reaction between acid and alkalis, or acid and base. We set base to be in the solid form. You will find that acid reacts with metal or metal oxide or metal hydroxide or metal carbonate. So base means that to be metal or metal oxide or metal hydroxide or metal carbonate. These are forms of base. So we have a reaction between acid and base. This base may to be metal or metal oxide and metal hydroxide or metal carbonate. For example, the reaction between hydrochloric acid and zinc oxide, zinc hydroxide, zinc carbonate, you will find in each case they will form, all of them will produce a salt. Plus, in case of metal, it will produce hydrogen. Metal oxide will produce water. Metal hydroxide produce also water, but the different imbalance. Metal carbonate, it will produce water and carbon dioxide. So all of them will produce salt, salt plus hydrogen, plus water, plus water, plus water, and carbon dioxide. For example, if you have the reaction between zinc and sulfuric acid, or zinc oxide plus sulfuric acid, or zinc hydroxide plus sulfuric acid, or zinc carbonate plus sulfuric acid, you will find that all of them will produce zinc sulfate at the beginning, zinc sulfate. For all of them, zinc sulfate, zinc sulfate. This is a salt. Plus, the first one will produce hydrogen. The second one will produce water. The third one will produce water also, but will be 2 by the balance. The third one will produce water plus carbon dioxide. So the reaction between acid and metal produce salt and hydrogen. Metal oxide or hydroxide, salt plus water. Metal carbonate, salt plus water and carbon dioxide. But there is a special case in case of using metal.